Okay, now I want to talk about what happens if we go, let's say, from the point R to the point F. So the vector from R to F. Now, the vector from R to F, we can go from R to P and then P to F. So R to P and then P to F. Now, what a lot of people would think is that R to P is just the same as vector k. Now, it's the same size as vector k, but it's going in the opposite direction. If we're going from R to P, we're going in the opposite direction to vector k. And that's really important in vectors because, like I said, direction is important. It's one of the two properties of a vector. So if we're going from R to P, then we're still going along the same line as vector k, but because it's in the opposite direction, it's just going to be minus k. Okay, so if you go in the opposite direction to a vector, it is the same vector, but it's negative. P to F is the same size as two of these m's, but again, because it's in the opposite direction, then it's minus 2m. So the vector from R to F is minus k minus 2m. Now I want to use that idea to answer an exam question. Okay, so here is a typical exam question. Now what you need to do with exam questions is read through all the information and add anything to the diagram which is going to help you. So we can see here we've got a little vector A which goes between Q and R. We've got a little vector C which goes between R and S. And now it says PQRS, which is this shape, PQRS is a trapezium. It also says that OP, so this line, is parallel to RS, which is obvious because it is a trapezium and trapezium have one set of parallel lines. And QP, so this line, is 3 times the length of RS. So if R to S is vector C, then we should be able to write down straight away that Q to P is 3C, because it's the same vector, it's going in the same direction, but it's just 3 times as big. So we can just write that vector as 3C. Now if we look at the question, express in terms of A and or C, which just means that our expressions need to have a vector A or a vector C in, QP. Well, we've just actually found the vector QP just by adding stuff to our diagram which we thought would be useful. So the vector Q to P is just 3C. And just a quick note, you'll notice that they don't underline the vectors when they type them up. That's because they can use the bold setting when they type it to make the letters bolder. Okay, but obviously we can't do that with our handwriting without it looking messy. So we underline our vectors instead of trying to make them bold. Okay, so we've answered question 1. That would be 1 mark. Now we need to go from S to P. So we need to find out what this vector is, S to P. Now we don't know, we don't know what that vector is, but like we said back here, we can choose any route to get from one point to another. So even though we can't go from S to P directly, we can go from S to R, we can go from R to Q, and then we can go, sorry, those aren't arrows, are they? S to R, R to Q, and then finally from Q to P. And we know what each of those vectors are, so we just have to add them all together. So S to P is equal to S to R plus R to Q plus Q to P. Now S to R is going in the opposite direction of C, but it's still the same size, so it's still C, but it's minus C because it's going against the arrow that you have there in C. R to Q, same thing, minus A, okay, because it's going along the vector A but in the opposite direction, so it's minus A. And Q to P, we already know from because we worked it out in the last part, is 3C. Then all you've got to do is collect your like terms. So I've got 3C here minus 1C gives me 2C, and I've got a minus A by itself. So my vector S to P is 2C minus A. So if we ever needed to use this line again, then we'd know that this line now is 2C minus A. That's the vector S to P. Okay, hopefully you're in a position to attempt question 1 of task B.